Okay, welcome back. So in this section, we are going to talk about how to use scatterplots. So what's the point? So scatterplots have a lot of usage in today's world, especially since you see in a lot of graphs as far as COVID-19 is concerned. So we're going to talk about how you might use a scatterplot to do what a scatterplot is used for, which is to predict and extrapolate into the future. So the first thing we're going to talk about is how can we do this? So what you need to do this is you need a graph or a line that fits the data best. We call this the line of best fit. So if I look at this, this is using scatterplots to write equations. You could read this, pause it, read it. So basically, like last section, we just made the scatterplot, and today we're going to get into what we actually do with it. So looking at these, there's three different sets of data. And as you can see, like in some cases, a line isn't the best fit, but there is a correlation between the points. Like for example, this one here, obviously, this is clearly a line. But in the second one, it's a quadratic, so you might have a parabola of best fit. In this case, you might have a exponential graph of best fit. So in certain circumstances, even though it looks like there might not be a relationship between the points in the data, there might still be a line that fits that data. And so like we're going to be looking at a graph in a second here that kind of isn't necessarily a line, because we know that certain things aren't going to continually go up and up and up forever. So there's different graphs that we want to use. So sometimes it's lines of best fit. Today we're going to be focusing on right here, lines of best fit. But just just keep in mind there are different ways to fit graphs to data other than lines. But today we're going to be focusing on lines. So just to kind of reiterate that point that I just made as far as like you don't always want to make a line. If I look at this graph here and I focus on the bottom graph, I like the blue one. The red one is a cumulative graph that's going to be going up, up, up all the time. But the blue one on the bottom is a graph that it says, this is the number of confirmed deaths for coronavirus in the country. So this is a very sad thing, but it's kind of like a way we can use math in order to sort of predict the future, right? So you can see like all the way up until here, the number of deaths, there weren't really hardly any deaths. And then as the last month or so has happened, there's been more and more people dying of this terrible thing. So you got this graph. You don't want to necessarily make it a line, right? Because you don't necessarily think this is going to go up, up, up forever. So there's different equations that you probably want to do. So this graph, you probably want to make something like this. So if there's definitely equations that have that shape. So you probably could predict when this will be going, and this is kind of what I wanted you to do in the last project, but we're going to look at it a little bit moving forward. But you can obviously come up with a lot of different lines that probably fit this data better than just a straight line. Today we're going to talk about lines because that's easy to do, but just remember, like for a lot of scatter plots, you can actually look at and figure out a lot of things from the data and extrapolate and figure out maybe what's going to happen in the future. All right, so let's get an example of this. So we could zoom in a bit. So we're going to figure out how to write lines of best fit. So this example says an ice cream shop keeps track of how much ice cream they sell versus the noon temperature on that day. Here are the figures for the last 12 days. So obviously when the temperature is higher, they're selling more ice cream, right? So that's kind of the correlation that we want to notice, right? So as the temperature goes up, 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 the sales go up, up, up too. So the first thing you do is you want to create a scatter plot from this data. So you can pause it and see how that was created, but essentially you just take each temperature point and plot it on the x-axis, and then the y-axis would be the amount of money you made when the temperature was that degrees. So 14.2 degrees Celsius. So that'd be this point, made you about $215 in ice cream. So that's where that point came from. So you can see there's a definite positive correlation between the temperature and the money that you make. So the next thing you're going to do is you're going to figure out a line that fits this data, and that's this yellow line here. So if you just draw a line that comes as close as possible to all points, and when you do this, you want to pick a line that's probably going to go through some points that you can use. So looking at this line, the next step is to come up with the equation of that line. And the reason I want to come up with the equation of that line is so that I can have a method to determine how much money I would make at any given temperature, right? So I want to be able to figure out, like, well, if the temperature is 20 degrees Celsius, what am I going to make probably around, right? What should I expect to make that day? So The way you do this is you pick 2 points. So choosing points, so the starting points chosen here were 16.4 and 325. So that's this point here, because obviously the line that we drew went right through it. So you can see that I'm going to use this point. And then the other point, and that's the blue point. And the other point, 22.1, 522. So when the temperature was 22.1, the other point right here that the graph went through. So when you draw your line of best fit, you want to pick 2 points that the graph clearly goes through, and the graph clearly goes through these 2 points, 16.4, 325, and 22.1, 522. And then from here, it's just all algebra 1 stuff. So this is where I'm just going to find the equation of that line using these 2 points. So the first step in that process, find the slope. So slope, so x1, x2, y1, y2. So slope, you subtract y2 minus y1 over x2 minus x1. You find your slope is 34.6, and then point slope formula. So using the slope, 34.6, and you could pick either point, but first point is easy, 16.4, 325. Point slope form here, y minus 325 equals 34.6, x minus 16.4. And then step 4, you're going to solve that equation for y. So this is all review. This is all algebra 1 stuff. So here's the steps involved. So this is a good page you want to probably write down somewhere in your notes. Make sure you have this so when you're doing these problems that this is going to be something that you're able to do. So then you come up with this equation. So the power of this equation is in the fact that, like I said a second ago, I can use this equation now. So let me just highlight this so that you can see what I'm talking about. So I'm going to use this equation to estimate or get a guess as to how much I'm going to make at any temperature. So like I said, if I take 20 degrees, so for example, if I take at 20 degrees Celsius, how much would you expect to make, right? So this is why a line of best fit is useful, because it can help me to predict things. So I'm going to plug in 20, and I'm going to solve this equation. So I pulled out my calculator and I did that while the video was paused, and it came out with $449.56. So that's a way to determine if the temperature was 20 degrees Celsius, that I would probably make $449.56. So that's the power of lines of best fit. That's what a scatter plot can do for you, right? So this is kind of what I was saying with the coronavirus. If I can figure out an equation that fits that data, I should be able to predict what's going to happen 20 days from now, 30 days from now, 40 days from now. It's not perfect, obviously, when you're dealing with, you know, the statistics in the real world, but it is definitely a way to predict. All right, so now we're going to get into some examples, and I want you to try these. So I'll let you pause this video, try it, and then we'll go over how we did it. All right, so let's talk about what we did here. So you got your 4-step process in determining how to find the line of best fit. So in this problem, they gave us the scatter plot, they gave us the line, and they even told us the 2 points you wanted to pick. So the only thing I really had to do is figure out where these points are. So this first point is at 0, 5. So that's this right here. And then the other point's at 9, 8. So that's this right here. So step 1 done, found my point. Step 2 is find the slope, right? So the slope is the difference in the y's over the difference in the x's. This is a positive slope. So that would be 8 minus 5 over 9 minus 0. So it ends up being 1/3. So step 2, find the slope, right? So that's 1/3. So step 3 is put this in an equation, right? So step 3 is to make the equation point slope form. So point slope form, y minus y1 equals m slope, parentheses x minus x1. So I chose to use this first point here, 0, 5, and I'll just put it in the form. So y minus y1, which is 5, equals 1/3 x minus 0. Right, so there's my equation. The other equation, obviously, and then the last step is to find your slope-intercept form, which is a real simple process with this particular one, because all I got to do is distribute this 1/3 to the x and to the 0, and that just gives me, bring it down, gives me 1/3 x on the right side, and all I got to do is add 5 to both sides. So it's going to cancel on the left. Y equals 1/3 x plus 5. So there's my final answer. All right. So hopefully that went well for you. Pause it. If you want to look back and see if you did, made some mistakes, it's a good time to kind of figure out how to do this. So now let's look at this last problem. And this one's going to require you to do everything, right? So it's going to require you to draw the scatter plot, find a line that fits the data, find the equation of that line. So a lot of steps in this process. There's the first two, drawing the scatter plot and drawing the line can be kind of tricky, but that's what this is about. So I want you to look at this data and realize, like, your x-axis and your y-axis are not going to just go 1, 2, 3, 4, 5, right? That's going to be a little bit bigger. So the highest value is 125. So I'm going to probably go up. Let's just do up every 2 ticks is 20. So just to make it. So oops. So every 2 ticks is 20. So this is probably a decent way to do it, but doesn't have to be the only way, right? So my x-axis is the number of negative consumer reviews. The y-axis is the number of cell phones sold. So in that case, I'm probably going to make every 2 ticks like 100, right? So in this case, I'm going to go 100, 200, 300, and so on, all the way up to 1,000, because it sees that the highest is definitely less than 1,000. So this gives me a good graph to kind of base everything on. So after this, I'm just going to pause it. I'm going to have you guys pause it. I want you to try to do this. Try to do it on a separate sheet of paper. See if you can figure out how to make this scatter plot, draw the line, and then come up with the equation of that line. All right, so I made the scatter plot and I drew my line, and I saw that my line went through 2 points, right? So I went through the point 106, 355, which is this point right here. And then I also went through the point 21, 925. So these are the points that the line of best fit went through. And so those are the points I'm going to use to do the rest of this problem. So if you had some trouble making your scatter plot or drawing the line, I'm just going to use those points. So if you want to pick up from here and finish this problem, then you'll get the same answer that I did. If you pick 2 different points, your answer will be similar, but it won't be exactly what I did. It'll still be okay as long as the slope is pretty close to what my slope is. If your slope is completely different, you're probably going to be wrong. But you could try it with the points you might have picked, but I'm going to pause and I want you to finish this and do the 4 steps of finding the equation of the line of best fit. All right, so finishing this off, you just did your 4-step process here. So number 1, find the points. Obviously, I told you that a second ago. Find the slope between those points. So y2 minus y1 over x2 minus x1 gives me a slope of negative 6.71. So obviously, that's a negative correlation, which makes sense. As the number of negative reviews goes up, the number of phones that are sold goes down, right? So that would make a lot of sense in terms of this problem, right? So the point slope form, I use the first point, 21, 925, so it's y minus 925 equals negative 6.71 times x minus 21, and then take that into slope intercept. To do that requires you to distribute the negative 6.71. And then add 925 to both sides, and it gives me this. And again, the power of this is to determine, if I have, if you have a certain number of negative reviews, you can predict how many phones you will sell, right? So if you say like I got, 37 negative reviews, right? So that's actually a number on here. But if I had like maybe 45 negative reviews, I should be able to use this equation to predict how many phones I might sell based on this table and based on the data. So that's why lines of best fit can be pretty powerful. So try it. There's gonna be so you're gonna have 2 IXLs. You're gonna do a one that's gonna help you write equations of lines, and then you're gonna do a line of best fit one. So hopefully this goes well. Should be pretty good. And these are the skills we're gonna be building so that we could use them to apply them to actually bigger problems. So hopefully this went well. And feel free to contact me or your teacher to determine how to do it if you have more questions.